Okay, so the rules for naming type 3 binary compounds. I don't like this name, type 3 binary compounds. These are formed between two nonmetals. I prefer to call these either molecular compounds or covalent compounds. They're two nonmetals. This does not involve any ions because, like, you can have a compound between sulfur and oxygen, but they both form -2 ions. How could you combine two negative charges and end up with a 0 charge? You can't do it. So they don't form compounds by making ions. They do it by sharing electrons, which we'll learn about later. So when we name these guys, the first element in the formula is named first, and we use the full element name for that one. So it follows the pattern of the metal, nonmetal, those ionic compounds, where the metal element has its full name. Okay, so if we've got nitrogen and oxygen, and the nitrogen is first, his name is in the formula is just nitrogen. The second element we name as though it were an anion, even though it isn't. So we change the ending of the name. And then we use prefixes to tell us, what is that? We use prefixes to tell us how many atoms of each element are present, because there are no charges to tell us. So when we write a formula, we have to write it in a way that somebody else reading it is going to understand what it means. So we use prefixes. And we never use the prefix mono for the first element. Mono is a prefix meaning one. And so just like we don't use the number 1 in the formulas, we don't use the word mono for the first element. These are the prefixes.
But you could use it for the second.
Yeah, we do typically use it for the second one. So mono means 1, di means 2, tri means 3. Those make sense to most people. Like a triangle has 3 sides. Tetra, that's like, well, do you remember the game Tetris?
Yeah.
What were you dropping in Tetris? Little shapes made out of 4 blocks, 4 squares. Some of them were 4 squares in a row, some of them were in different shapes, but they all had 4. Tetra is a prefix that means 4. I don't know if that'll help you or not, but there it is. Penta is like a pentagon, 5 sides. Hexa means 6. A hexagon has 6 sides. Hexa and 6 both have X in their names. Hepta is a weird one. Hepta means 7. Octagon has 8 sides. Octa means 8. And there's also nona and deca. Nona is 9 and deca is 10. So let's look at some examples. CO2. The first thing we have to do is identify what kind of a compound we're dealing with. And we do that by looking at the first element. Up until now, everything we did was ionic. We look at the first element, carbon, and we ask ourselves, is it a metal? We look at the periodic table and we say, no, carbon is not a metal. Okay, so I've got two nonmetals. This is where I can use the prefixes. So carbon dioxide. We don't use mono on the first one. There's 1 carbon, but we don't say monocarbon. There's 2 oxygens, so it's dioxide. Carbon dioxide. SF6. Always ask yourself, that first element, is it a metal? No. Sulfur hexafluoride. So it's sulfur and fluorine. The first element just keeps its full name. The second element changes the ending of its name. Fluoride, hexa is the prefix that tells us there's 6. N2O4. Is nitrogen a metal? No. And oxygen is not a metal. We've got 2 nonmetals. The thing with these prefixes is students like them too much, and they try to use them everywhere. Okay? You can only use it when you have 2 nonmetals. 2 nonmetals. Okay? you're still going to do it.
Why does it eliminate the A?
Why does it eliminate the A? That's a good question. So we would expect this to be dinitrogen for 2 nitrogens, tetraoxide. A lot of times these prefixes all end in a vowel, usually an A or an O. And then when we get an element like oxygen or iodine or something that starts with a vowel, we can end up with some odd vowel combinations. So when that happens, we will often drop the last vowel on the prefix. So instead of tetraoxide, it's tetroxide. That's a subtle point on the multiple choice exam that I will not be out to trick you on that, to see if you remember that. Okay, so we use the correct names, and it's good to understand why, but I'm not going to really hold you to that one. So here's an example. What's the name of this compound? Is selenium a metal? No. So we can use prefixes. Woohoo! So selenium, there's only one, but we don't use the prefix mono. And then what do we do for that 2 oxygens? Dioxide. Now, see, we don't always drop that vowel. Di is a prefix that ends in a vowel, and oxygen is an element that starts with the vowel, but we don't drop the I and say doxide. That'd be weird, huh? Dioxide. And so that dropping the vowel thing, sometimes we do, sometimes we don't.
There's a double syllable, 50 syllables, which I do.
That's more common, yeah. And diiodide looks weird because it's got 2 I's in the middle. They're together. But we don't drop the I. It's diiodide. So that was multiple choice. And see, in here we've got selenium oxide. That would be naming it as a type 1 ionic compound. Here we've got the correct name. And here we've got trying to name this as a type 2 ionic compound. And then, but with the wrong charge. And here's with the correct charge, I guess, if it was a metal, but throwing a prefix in there also. And that's just like, that's, yeah, just grasping at straws on that one. So here's a flowchart for naming binary compounds. So the first question to ask is it a binary compound? What is a binary compound? It has 2 elements. If yes, then you ask yourself, is there a metal in it? If no, then it's a binary covalent compound, a type 3, and you can use the prefixes. If there is a metal present, then you have to go down this side and ask, does the metal form more than 1 cation? What we're looking for there is it in group 1, 2, or 3? If it's in group 1, 2, or 3, it only forms 1 kind of cation, and we just use the element name. If it's not in group 1, 2, or 3, then we have to specify with a Roman numeral.